So just rock up and look shocked and you do the research? Is that how we're doing this?
Yes.
Okay, cool.
Because you're the smarter one.
Just a pretty face,
Yeah.
right? I don't know if my brain's going to the right places, but obviously, like within structures, the stress goes to the strongest point.
I've actually never thought about it in that way, but yes. But now when it comes to foundations,
And as an engineer, if someone started tearing around my designs, I'd start
so
We
yeah,
have a name now.
we have a name now.
Yeah.
Yeah.
How did we come up with a name?
I don't know. You came up with the name. You gave me a bunch of choices to pick from, which was nice. You know, a lot
I
of
had some help.
Okay.
I had some help.
Okay, with
ChatGPT.
yeah, yeah. You better love technology, right?
Right.
It's great. It's great. Great utilization, by the way.
But you chose it.
Yeah, yeah.
What did you choose?
Engineering antics. Right. That was two good potential candidates from that list that you sent me, and I thought that one was.
What's the other one?
I'm forgetting the other one.
It doesn't matter anymore anyway.
Yeah, we can try it maybe some other time. Let's see how this this name goes. Then we can switch.
Chido and Antonia engineering antics.
Engineering antics. But I removed our names. Yeah, I removed our names because it would have been too long. Okay. Because my name alone is just it's too long.
I still can't say it. Chido
Yeah, Chido Chash. Close enough.
I still can't say it.
Alright guys, welcome to our second video on our channel, Engineering Antics. My name is Chido Chash. I'm a geotechnical engineer. I specialize mostly in the subsurface.
I'm Antonia, and I'm a underground structures engineer who's mainly been focused in underground structures and tunneling.
Cool. So yeah, in our last video, which was our first video on this channel, we reacted to the Millennium Tower in San Francisco. If you're not familiar with it, you can go and watch our first video. It's a long one. A lot of waffling in there, but it was good. I really enjoyed making that video, even the editing as well.
Hey, you get to learn about us as well in the video.
Exactly. If you want to learn a little bit more about especially structural tunnel engineering, you went on for 15 minutes.
Hey, you went on too.
Right.
There's a whole section on liquefaction in there, isn't there?
Right. Yeah. Towards. Yeah. So I encourage you guys to go and check that video out. I think it's a good one. I think it was for a first video. It was really good. Yeah. And please like and subscribe to the channel. We are trying to make this our day job. Just live off YouTube, ad revenue, and just dump our engineering jobs and just make YouTube videos.
Sounds like fun.
Sounds like fun.
Yeah. I'm all for that.
Me too.
Let's do it.
Yeah. So in the last video, you were left with a lot of questions about.
I had so many questions.
So many questions. Yeah, I could tell.
Yeah, well, you just showed me a video about a building.
Which is sinking.
And tilting. And cracking, and I wanted to know why.
Right. Okay, so that's what we're gonna get into today.
Okay.
The reasons why it's sinking and some of the potential fixes.
Interesting.
Yeah. It is. It's going to be interesting. So let's get into it.
Okay. I kind of want to ask questions before I watch the video.
Okay. Yeah. Let's just quickly ask you questions so that we get into the video.
Just watch video.
Video first.
Yeah.
Okay.
I'm preventing a 15-minute ramble about something unnecessary.
Yeah, we usually end up doing that.
It's finally happening, the final phase to fix San Francisco's leaning and sinking Millennium Tower. It's underway. We've obtained an analysis by the team in charge of the fix. That analysis shows, at best, the fix will correct about half of the additional tilting that occurred during the project to stabilize it. Some experts warn that prediction could be overly optimistic. Here's investigative reporter Jackson Vanderbecken.
Here at the Millennium Tower, crews are struggling to keep the water out of the holes they're digging to extend the foundation down to bedrock. Crews are preparing to shore up the building on the two sides where it's leaning the most.
Hang on. This is the video to fix it. Do we watch a video of the problem? Or is it talk about the problem in this video?
Oh, like, yeah, we...
You told me the bedrock problem, but they didn't tell us the bedrock problem in the video.
Yeah. Like, in the last video that we watched, they didn't really get into the problem. Yeah. They just spoke. And the other thing about this whole project, right, it's kind of like shrouded in secrecy because it's now a court case.
Yeah.
So, yeah, there's some documentations which are not out in public.
Okay.
Yeah.
You were just speaking like you knew so much about it, and I was like, where did you learn it?
Yeah, I had to do like a research, outside of just watching YouTube.
Okay.
Yeah.
So I just rock up and look shocked, and you do the research. Is that how we're doing this?
Yes.
Okay. Cool.
Because you're the smarter one.
Just a pretty face, right?
No, you're the smarter ones, right? You're the smarter ones. So,
just bring in some
from
feminine energy.
the top of your head.
Just bring in some feminine energy to the channel.
And that as well.
Okay, cool.
Yeah.
Lots of laughs. All right. Cool.
So, no questions?
I'm excited to see how they're going to fix it. Do they have to like sink it to level it, or they can't lift it up, right? So I've got so many questions.
Right.
Yeah.
Tying it to 18 piles already sunk to bedrock.
No building should really have that sort of tilt, not a modern building of this nature.
Harry Poulos is an internationally recognized expert on tall building foundations. The tower is currently leaning a little bit more than 29 inches at the northwest corner. More than a third of the tilt coming after work on the fix started in 2021. How much is that for people who actually live in the Millennium Tower? Take a look at this marble. An owner rolls it uphill toward the center of an apartment until it runs out of steam and gravity takes over, taking it right back where it started.
If I was a resident, I'd still be worried that I can't put something on the table without it rolling off.
Although the fix is supposed to provide some relief, the fix engineer's latest computer model shows the $100 million project will only offset a total of 4.5 inches of lean. That's less than half the tilt added to the building during the construction project intended to stop it from leaning. The final result is projected to leave the tower secured, but still permanently tilting about 2 feet at the northwest corner. Fix officials say the project will succeed in stopping further settlement and sinking, well before there's any safety concern. In a statement to us, lead fix engineer Ron Hamburger says the primary objectives have always been to arrest building settlement at the northwest corner and stop tilting by transferring a portion of the building's weight to bedrock. Recovery of some of the tilt that has already occurred is a secondary benefit, not a primary objective. City experts are satisfied with the model's conclusion, Hamburger told us. But some critics fear the model predictions could be overly optimistic.
There's a lot of...
They're going to give people refunds on their freaking houses? Like, what the hell? We just want to stop the sinking. We're just going to leave the tilt, though. Hope you don't mind.
Yeah, at this point, it seems like they're just doing just enough so that the building doesn't collapse.
I was actually curious. Do you know the dollar values? Like, how much they invested in building versus remediation?
Okay, so... I'm not really sure about the exact numbers, but fun fact is this. If they at the initial construction of the building, if they had extended the piles to bedrock, it was going to only cost about $4 million.
Yeah.
Now, I think it's 10 times.
No surprise.
Yeah.
No, not at all.
Exactly.
Not even remotely.
It's not even close. If they just done the right thing from the get-go.
Okay, so it wasn't... Okay, so... Because I don't actually know what you've found in your research. So them not hitting bedrock had nothing to do with them not, like, following design. They literally was... The piles were not designed to hit bedrock originally.
Yeah, the piles were not designed to hit bedrock.
Okay. Yeah. Sorry, I think after the last one I was a bit confused.
Yes.
Okay, so... According to design, they didn't need to.
According to design, they didn't need to. So, but then from designing a building like this, I think someone should have at least recommended. And as you shall see, some other people, right, external consultancy, they actually raised those questions, but they fell on deaf ears, I guess.
Sorry, like during design they raised the questions.
That's
interesting.
Yeah, some external reviewers raised some questions about that foundation.
Oof. Well, if you play it, yeah. Is it in this video?
Maybe in the next one.
Okay.
Yeah, we'll watch that one.
Because then my brain's going, what was the concern? Was it the uncertainty in the soil conditions, or was it that we know this is shit soil, we need to hit bedrock, so we've got a good bearing capacity to work with? Like, what was it? Both?
We'll see, like, what the engineer says. I think it's in this video or the next one. But if not, like, I'll try to explain it to you how I understood it.
Okay.
All right.
There's a lot of uncertainty.
Deep Foundation expert David Williams worries the model doesn't simulate what's actually triggering construction-related sinking, or explain why the tower ended up tilting more than the model predicted last year.
There's a lot of factors that they have not accounted for.
Meanwhile, residents are coming to grips with reality that the building likely will lean forever. But just to make sure about that marble, one owner repeated the test. Once again, it came right back to the northwest corner of the apartment. Jackson Vanderbecken, NBC, Bay Area News.
This has been going on for years, and Jackson has been digging into the problems at the Millennium Tower that entire time. You can find all of his exclusive reports on our website, NBCBayArea.com. Just click on the Investigations tab.
But so far, yeah. From the information that you've gathered so far from our previous video that we reacted to in the first one, then this one. Has any of your questions been answered yet?
I'm just... well, I think... no.
But at least now we know that...
They mentioned it was construction related as well. Didn't they say construction tilting or something? Well, I can't remember what words they used. Okay,
so now, right, they tried to fix it. So what they did is, you remember the side which is tilting and sinking? Mm. They installed 18 piles to bedrock. Yeah. And the idea is to try to equalize the settlement. Yeah. So not stopping the settlement, but just equalizing so that the other side can settle as well to reduce the tilting. Right. But then now it's tilting faster on the other side. Right. But like putting the fix and the problem aside. Yeah.
So this side's lower than this side. They've now stabilized this side, and this side's going faster.
Yeah, now...
When it gets equal, can they just stabilize that side and then move them together?
Yeah, I think that will be...
Is that what they're doing?
Yeah. I think the best way will be just to drill piles around the whole perimeter of the building and just make sure that they are anchored to bedrock.
I'm like, yeah. Once it's even. Once it's even.
If it ever gets even. Yeah, if it ever gets even, I think that would be the best solution. But the way they actually did the retrofitting and the underpinning of the piles, it's actually an interesting novel idea behind it, because they used a mechanical device to connect. The piles are not directly underneath the building, so they are next to the building. The building is here, the piles are next to the building. Then they used a mechanical device to connect the piles in the building. And it's an electronic jacking system to measure the slightest settlements.
It's so freaking cool.
Yeah, I know.
That is so freaking cool.
I know. And it's set up in a way that if the other side starts to sink at a faster rate, the mechanical device will just snap and release the building.
Okay, wait.
Yeah.
through instruction we can snap it, or it'll snap automatically?
I think there's it's automatic, but there's redundancy set in place to in case that the.
I was like, what if there's a false measurement or something happens and then they're snapping that, and then that's my brain went.
Yeah, but I think it's a it's a dual input system.
Okay.
Yeah, they won't be reckless in that way again.
Okay, I'm like sporadic decisions.
Already they're walking on a tightrope. So I think now they're being a little bit extra careful.
I want to see this.
Okay. All right.
No, like I want to see this mechanic. Like, how does it? It's obviously has to transfer the load to the pile as well. So it's like, it's not just a measuring tool. It's an actual like load bearing.
Yeah, it's a
structure, whatever
load bearing structure. Yeah, the mechanical device itself. Yeah, it's well designed.
That sounds trippy.
Yeah. But okay, we'll watch that after this one. I have that video which explains that somewhere close to.
Two things that were mentioned in there that were new. That it was there's something about it being or maybe I'm missing pieces of the puzzle. That could be why.
Okay, like what?
Because it was a construction settlement. Was that what you were talking about?
Yeah.
Okay. And then they obviously mentioned the modelling. When they said, well, how come the model's settling more than what? Sorry, the building settling more than the model. Is this the model post, like remediation model, or is this model during like design?
I think this is post remediation.
Okay.
Yeah. Right. So
they're modelling to remediate the building, and
it's not matching. Right. It's not even matching with the.
So that points
with the simulations. Yeah.
So that kind of highlights some stuff around what probably happened in design too.
Yeah.
Okay.
Yeah. That's what I said. Like some of this information, you have to go and dig deep in the.
They can't model the remediation model correctly. Odds are there's probably something going on in the.
Exactly.
Design model.
Design model itself, right? So now it's not only.
Now that they know what's happening in the ground.
Yeah, as you will find out in the next video. Now it's not only a foundation problem. There's a structural problem as well.
Yeah.
So, yeah. Okay. So let's watch the second video. Then we'll give a comment again. After.
Well, more trouble for the troubled Millennium Tower. It's been 6 months since the luxury high-rise was fully supported to stop it from sinking and leaning.
Now, that project was hailed as an immediate success, but NBC investigative reporter Jackson Vanderbrecken has learned that the high-rise is no longer sinking any further to the side, but now it appears to be sinking in the middle.
Here at the Millennium Tower, you can see the construction crews and scaffolding are all gone, and even the cracks that once marred the front of the high-rise are now gone. No signs of the 3-year effort to stabilize the Millennium Tower by supporting two sides with 18 piles sunk to bedrock. Fix engineers had predicted once that was done, the tower's weight would shift onto the other sides and eventually right the tower by as much as 4 inches. But they now acknowledge that projection was overly optimistic, saying the soil under the building is not acting as predicted. Instead of sinking at the opposite edges and offsetting more of the tilt, the tower now appears to be sinking in the center.
With all tall buildings, there is a tendency, even though the foundation mat may be quite thick, there is a tendency for the center to settle more than the edges.
Harry Poulos is an internationally recognized expert on tall building foundations.
That had a name. You called it something last time.
Dishing. Yeah.
Cool.
He says that data suggests that even as the sides are not sinking as much as hoped, the tower is still settling at an overall rate of about 1/10 of an inch a year.
1/10 of an inch is not that much, but it's not heading in the right direction. And that would be a little bit of a concern for the longer term.
The overall situation is very complex.
Geotechnical engineer Robert Pike says center sinking, known as dishing, can trigger cracking under the foundation.
That should have been obvious that there was a possibility of further increasing cracking and water intrusion into the foundation.
Pike says this buried wall under the opposite side of the foundation may be another hitch. Engineers figured the wall would sink when more weight was shifted onto it and help right the building a bit. But so far, Pike says, monitoring data shows the wall is holding fast. The designer of the fix project, Ron Hamburger, told us in a statement the remainder of the building continues to settle as we always anticipated, resulting in tilt recovery, albeit at a slightly lower rate than modeling predicted. He added, "We believe the lower rate of settlement was because stress relief on the soils under the building has been more effective than originally forecast. As it stands, the tower is now tilting about an inch less than before, now leaning just under 29 inches at the northwest corner." Jackson Vanderbecken, NBC, Bay Area News.
It's been quite a saga. If you have a story for Jackson or anyone else in...
Still more questions?
Sorry, I think my brain was going on a tangent as he was talking about the wall. They've designed a wall that they wanted to sink, but it's now too rigid and that's not sinking, and that's a problem. Is that what they said? I kind of caught the end of that.
Yeah, I didn't really understand that part as well. Hey, I didn't really understand that part. Like, what?
Where's the wall? What's the wall?
Maybe it's that wall. You remember that wall which was peeling off in the first video that we reacted to?
Yeah.
Yeah, you remember there was that wall which was peeling off and the reinforcement was exposed on the surface. Maybe that's the wall. Yeah, maybe that's the wall that they're talking about. But don't quote me on that. Like,
that's just so funny. But it was just like they were saying that they wanted the wall to sink, but it's not. That's a bad thing, is what I just heard.
Oh yeah. Yeah, I think it's because remember they're trying to equalize that tilt, right? Yeah, so they have to make sure that it sinks in the other direction at a faster rate than this one.
I get that, but just the irony behind was the wall designed to freaking sink.
But then it's not.
Like...
It seems like it never ends, right?
Okay, and then they were saying it's sinking more in the middle now.
Yeah. Unintended consequences, I guess. Like from what they were trying to do. So it seems like at this point, right, they are looking for solutions for a solution.
It just, please correct me if I'm wrong. It sounds like they have no idea how this structure is behaving.
Yeah.
In any way, shape, or form.
Yes. Because the models, their models are right. Their models are not matching with their prediction models are not matching with the actual behavior of the building.
No idea what's going on.
Yes.
Where is the light being transferred? What's supporting it?
Supporting it?
No clue.
Yes.
Okay.
At this point, I think it's just that they're at a point where they've spent so much money to turn back. But I think they're going to get to a point where it would have been cheaper just to demolish it, right, than to try to keep on fixing it and coming up with all this.
It's about the money. But I guess when they first did the remediation, they didn't realize it wasn't going to work.
Yes, of course, on the money issue, of course, because everybody was so, like, who bought an apartment in this building, they've placed a civil lawsuit. So they will need to be compensated for their money there. And
it's big.
It's big. It's big.
It's big.
More bad news.
Well, the other thing they mentioned, they said that the soil was more of the stress was getting transferred into the soil than they anticipated. So that the soil was actually supporting the structure more than they realized.
It seems so.
But in some locations, not others.
Because it seems so. Because dishing, right, it's supposed to be minimized if all the piles are anchored in bedrock, right, which means the settlement is going to be like somehow equal across the whole footprint of the building, because all the piles are designed to have the same settlement. Right, like pile design, let's say the allowable, right. So, which means dishing is less likely to happen. But it's possible, it's happening because all these piles are not are not attached to bedrock. So some piles are sinking faster than the piles at the center are sinking at a faster rate than the piles on the perimeter of the building.
I don't know if my brain's going to the right places, but obviously, like within structures, the stress goes to the strongest point, where it's getting the most support.
Yes.
And so it's...
I've actually never thought about it in that way, but yes. But now when it comes to foundations, it goes to the weakest side, because that is where it's less supported. So it sinks, because it's not only a structural problem, it's a soil structure interaction problem. Right. So the soil which is the weakest is the one which will just fail.
I'm trying to think about reframing the word that I'm trying to say.
Yeah.
This is a thought experiment for me, and I'm conscious I'm on camera, so I want to think about that and come back to it.
Okay. let me know if you think about it.
I want to see where my brain's going with the concept.
I'll give you some time to do something.
I'll do my thought experiment later. I'm explaining things to myself in my brain.
Alright, so yeah, this one is more bad news for San Francisco's.
Are you showing me these in order as well, like of when they happened?
Yeah, they're kind of random, just to spice
okay, whatever.
Yeah,
that's cool.
Millennium Tower owners, still reeling after learning the tower is sinking and tilting, now have something new to worry about.
NBC investigative reporter Jackson Vanderbecken tells us that there is a new concern, and that's a potential quake vulnerability hidden inside the walls of that 58-story tower.
What else? What next? Go on.
I told you, I think at this point it's cheaper to just demolish this thing.
At what point is that? We turn around. Wait.
How else would we know? That's right.
Before Andrew Falk bought his 50th floor unit with his husband in 2011, the couple...
Thought experiment as well here. Is the reason we're finding so many problems because there is a problem. And maybe all the infrastructure that we build maybe has things that we're not sure may be wrong, but we never really find them because it's not a problem to explore it unless it is. Does that make sense?
Yeah, I see what you mean. Like
if we weren't so fixated on this tower, with
these problems would have not shown up. Yeah, most likely.
Which is interesting thought, but anyway.
Yeah, that's an interesting observation. But yeah, right. Because now it's like they're nitpicking on like the little.
That's wrong.
That's wrong.
That's wrong. That's wrong.
Yeah. And it makes sense, right? Because more eyes are now on it.
Yeah.
Right.
In saying that, if their models in the beginning weren't sort of done correctly, then shit.
Yeah. You know, these are actually not little things, but all these other things would have just gone unnoticed.
The couple asked how the Millennium Tower would handle earthquakes.
And we were assured that it was state-of-the-art and that it would do just fine.
It turns out that Millennium's assurance was made based on results from a relatively unsophisticated generation of computer modeling done back in 2005. But a more advanced method, commissioned by the developer 8 years later to account for Millennium's sinking and tilting, identifies a previously hidden problem. It's here with the mammoth blocks of steel-reinforced concrete known as outriggers. They are supposed to bind the tower's core to its outside walls and absorb the bending and twisting exerted in a major quake. But 8 of the tower's 12 outrigger blocks won't be up to the challenge, Millennium's own analysis shows.
It's not a good thing.
Bob B. is a UC Berkeley engineering professor emeritus. He has long analyzed what goes wrong in major infrastructure projects like the Millennium.
If they don't work, you're in deep doo-doo.
In a report to the city in January, Millennium's own veteran structural engineer, Ronald Hamburger, details the findings. Near the top of the building, he reports, the outriggers are about half as seismically resilient as they should be. And the next set down will be overtaxed by 20%. While not making any specific predictions, Hamburger ruled out collapse. At the same time, he warned that overstressed outriggers could break apart and suffer loss of strength. The building could be red tagged after the quake as a result, says veteran structural engineer Joe Maffei.
It's one of the drawbacks of an outrigger design. Outrigger designs are wonderful for wind. You have to be very careful with them for earthquakes.
Maffei says the question is just how severe a quake it would take to make the building a total loss.
He could figure out what level of earthquake he thinks is going to cause that red tag. And if I lived in the building, I would, you know, for the cost of paying one of those fancy lawyers for a couple of days, you could probably get Ron to run that analysis.
I like how he's trying to choose his words carefully. He was just supposed to say, if I was one of the people who live in that building,
just tell them freaking go do
freaking
go pay the bloke. It's gonna help your court case. Go for it.
He was like tippy-toeing around.
I know he'll find something.
Millennium says the building has been repeatedly evaluated and declared seismically safe. In a statement, they told us, quote, at every step of the way, the building has been determined to be safe for occupancy. Since before construction began in 2006, both the city and Millennium's experts have declared the building as code conforming. But we discovered that back in 2005, one of the outside consulting experts, Hardeep Panu, urged that the designers do the more sophisticated type of analysis for the outriggers to, quote, investigate performance of these important elements and bring factor of safety for them to a desirable level. The project's engineers said that was unnecessary, as the outriggers were designed based on well understood and well documented principles. B says owners should demand more information as they themselves assess the risk.
Would you tell the people that live there they ought to move out?
Well, I can't tell people what to do. And here is getting back to, you need to tell people what risks they are really facing. And at that point, let them make the decision.
We really don't know what to do.
Meanwhile, Millennium owners tell us they feel both angry and helpless, unable to sell or move because of all the troubles.
And we find out now, after we bought, that the place isn't safe. We're appalled.
Jackson Vanderbecken, NBC, Bay Area News.
I'm not quick to jump either way on this.
Yeah.
Because I'm conscious of politics and media attention and stuff right now.
Okay.
Is it as bad as they're making it sound?
It seems bad because, like, not even talking about this specific building. If this is to happen to any other building, like one building having so many problems.
Are you talking about the earthquake, or are you talking about sinking?
I think now it's a twofold problem, right?
How I interpreted that the seismic concern that they have with the outriggers, they've obviously done a more complex model.
Yes.
And found that the outriggers are not actually complying with standards now based on this new model, the outputs they're getting at. Complex doesn't always, in my mind, mean better.
Yes. Yes, you can have a sophisticated modeling application, but if you don't have the right inputs, then garbage in is supposed to garbage out.
Exactly.
Yeah.
I could be wrong. Maybe it's not designed to comply, but their preliminary models supposedly do comply with standards.
Right. But then standards evolve, right?
Well, then that's then saying every building that was designed before our standards were created needs to be torn down.
Yeah.
So like.
Yeah, which is not practical, right? And like, it's not economically feasible as well.
Well, before we even had seismic modeling tools.
Yeah, it was hand calculations and, you know, just.
Sorry, this is a different wrap-up. This is a different rabbit hole.
Yeah, but anyway.
The flag is that someone said we should do a more comprehensive model in design, and they didn't. That's the flag.
Yeah.
Someone obviously highlighted it.
Yeah, but they chose to go with whatever model that they used to initially design the building.
And the justification behind that would be interesting. How can they, given what made them go with so much certainty that we have enough certainty in this simple model to know that this building is designed safely?
Because you would need because most of the times, right, you do like a model calculation, then at least another consultancy should do their own modeling.
They do. Well, they do here.
Right. Right. So that you compare the results, right? Or just do an external review.
We literally have, on the last project I worked on, we had a challenge team.
Okay.
So pretty much on the last project, I had my model. The package lead had his model, which verified my model.
Okay.
And then the challenge team would create their model to verify and when they're reviewing our work, to verify our models.
Right. So then they put on comments on the things that they need a little bit more explanations on. Right. This like a robust way of doing reviews. Right.
It's not flawless, but yeah.
Yeah, it's obviously, there's some loopholes and some things can be missed, but at least it minimizes, the risk of some of mistakes like this. Because this is, to be honest, this is not supposed to be, a mistake made.
This is one of those things that they wouldn't know it was a mistake unless they were started investigating this building.
Right.
There's no earthquake to actually prove that these outriggers can't support the earthquake. And what magnitude earthquake? What's the occurrence of this earthquake that it's failing against? Like what?
Right. There's the risk factor, right? Because when it comes to design of earthquake proofing, right, and earthquake system, you have to check the zone that the area of the building is located, or whatever infrastructure is there, and there are usually zones, right? So each and every zone is a unique earthquake factor, right? So that plays into the design of right,
which by the sounds they're hinting at is not aligned with where
it's not aligned
based on what they're hinting at, but. Yeah.
But anyway, this has been our second video, which seems like it still left you with a lot of questions, but
yeah, well, by the sounds of it, it's turned into this big media stunt thing. So I'm not media stunt. It's a huge thing on the media. So the more they find wrong with it, the more eyes they're gonna get.
Right.
So they're going to probably keep finding things wrong with it.
Most likely. Yeah, most likely.
And as an engineer, if someone started tearing around my designs,
yeah, I think it's I
get it. But no, it's interesting. It's interesting.
Right. All right, guys. This has been our second video. Please drop a like and subscribe to the channel. I'm sure Antonia will really appreciate that.
I will really appreciate it.
Right. Okay. So see you in the next one.